Hey, how's it going, y'all? Today, so we're going to just go over another Leetcode problem. This one is called populating next right pointers in each node. So I've actually never seen this problem before. So I kind of want to make this video be more like a how I would go through the problem, how would I would approach it. Um, so you can kind of get an understanding of how you can come to a potential solution. Alright, so let's go through the problem. You are given a perfect binary tree where all the leaves are on the same level, and every parent has two children. Every parent has two children, okay. The binary tree has the following definition: left, right, next. Um, Populate each next pointer to its right node. If there's no right node, if there's no next right node, the next pointer should be just set to null. Initially, all next pointers are set to null. Okay, so I mean, it just seems like we have our tree, and then depending on if we have extra layers to it, like if there's like a node next to it, then that'll be pointed to the right, or I guess like the level. So I guess immediately I can sort of determine that this could be done using a level traversal, just because we are the primary goal of this is to determine what's on the right, or not right, or like the direct, or like level, same level node. It's not necessarily like the children below it. And if we perform like a level order traversal, that just goes from the top where we have one. Um, we go from one, and then the next time, and then we'll check this. I guess this array, and then we can just iterate through it, setting the right to whatever next value we have. So I guess a potential solution could be something like um, let q equal an array. Inside this array, we can set the root. Do we want the root or the value of it? We want the root, because the value wouldn't do anything for us really. And then we can do while q dot length is greater than 0, and so we need to make sure that when we're going through our queue, we need to indicate when we move on to each level. So how I like to do this normally is I'll set like a new queue. So I'll do like let temp equal q, and then while, let's see, q dot length is greater than 0, and let's see, so I'm going to have this array. So temp is equal to q, and how do I do this again? I do temp dot length. Do I iterate through temp? Okay, so when we have our initial node, I check if we can iterate through it, and then I'll grab the array. Oh wait, no, this is supposed to be an array. And then as we iterate through q, it'll start adding to this, and then once we're at the end of this, that's when we can do temp is, or sorry, q would be equal to temp. So the idea is we're going to, first iteration, I'm going to have the root, and then once that's done processing, I would have put the children within it, and that the children, this array, this 2 and 3 will be set to q, so this loop will go again. The reason for not having a single loop is because I wouldn't know when the levels would end unless I had another indicator. If I did all in one loop as I'm populating, so this way I can take everything out of the queue, put it into temp, or the next level into temp, and then move forward from that way. It'll make sense once I start doing some more work. All right, so if I do q.length is greater than 0, then if, let's see, let, what's it called? Node equal q dot shift. Yes, this will give me the first element, I believe. Yeah, so this is the node, and then if node dot left, then we'll do temp dot push left, right? Node dot left. And if we also have node dot right, then we'll do temp dot push node dot right. So this is just sort of to make sure we're going through each level, but then we also need to make sure every time we have the node that we're working with, do we still have values within our queue array? And if we do, then that will point to the next one. So let's do q node dot shift. Let's see. So if q index of 1, because this would be the node right after the one that we, oh no, so we would want to do q dot front peak. Okay, let's just do this. Q0, if that exists, then we know that there's a node that we can point it to. So we can do node dot right is equal to q0. Otherwise, we would want to do node dot right is equal to null, I believe. Yeah. So every time this will go through, we'll shift and see if we can do something with it. And if q does have a value within it still, I guess this could also just be q.length greater than 0. Then we can do node.right is equal to q, the 0 index, and then otherwise we'll set it to null. And then after that is done, we're going to do q is equal to temp, where temp we have all the children nodes. And so since we're checking for if it's null, say we had like a missing child here, say 5 was gone, it would have a 4, 6, 7, right? So then we would have 4, and then the next node that would have been added would have been the 6, because we add the children of 2 and then the children of 3, and then it goes in that order, and if 1 is missing, it'll point 4 to 6. And so with that, I'm not sure what we return here. Return a node. Do I just return the root? And yeah, I think that should do it. I have a runtime error. Node left. Cannot read properties of null. Why is that? Is it not left? Okay, it is left. So node is equal to q.shift. That'll be the very first node that we're working with. Temp.push, node.left. Why does it think it's null? Oh, I see. So what if the root is null, right? If the root is null, we can't do anything about it. So let's see. I have 1, 2, I have a 3. Is there something that I need to be adjusting here? End of each level, okay. Node.write is, okay, let's see. Q.length is greater than 0. So yeah, I do eventually remove it. So then node.write. Oh my god. I was setting the node.next. That is my bad. Cool. So let's just check that works. All right, so it does work. Yeah, so make sure you read the problem. I definitely, for some reason, thought it was gonna be right here. I don't know why. But yeah, it was next, so that was the issue here. But I hope that makes sense for like how I approached it. And it's more just like, I mean, there are different ways to traverse these trees. You have like DFS, BFS, and then the other variations where you have like in order, pre-order, and etc. And because I'm aware of like the different ways to go about these trees and the common patterns, I can determine what I would want to do for this tree or for this problem. Time complexity, I'm pretty sure this runs um, order n. I mean, we're going through every node once. Um, and then space complexity, am I using any extra space? I mean, no, not really. All the space is already there, so it'd be constant. I mean, I do have this queue that will kind of keep track of everything, so I guess at max we would be dealing with um, 2 to the n levels where yeah, 2 to the no, I think it's, I forgot what the equation is, but it's basically the space will be whatever the max level is for the max height, if it's fully balanced. Um, if not, you can just sort of indicate that it would be equal to the lowest level of the tree at max. I mean, the interviewer would understand as long as you explain that. But yeah, that is it. If you like the video, please like or subscribe or comment. Yeah, I'm hoping to do more of these things, and yeah, this is also my second video, so sorry for being a little rusty, but yeah, thanks for watching.